Hello viewers, I am Maitli. Today we are going to see 9 CBSE Max Polynomial Exercise 2.2 third sum. The third sum it's given that verify whether the following are the zero of the polynomial indicated against them. So they have given a polynomial and they have also given a number to be substituted. They have asked whether that number is a zero of the polynomial. For a zero of the polynomial, the resultant answer should be equal to 0. If we substitute any number, if we get 0, then it will be a 0 of the polynomial. Other than 0, any number plus or minus any integer or any fraction or any number, it will be any real number, it will not be a 0 of the polynomial. So remember that you need to get the answer 0 for a 0 of the polynomial. In the first sum it's given that p of x is equal to 3x plus 1. Substitute the value of x as minus 1 by 3 because they have given x to be minus 1 by 3. If I substitute minus 1 by 3 in the x place, here it gets cancelled because it is the numerator and denominator. You can cancel in multiply when the same number in numerator and denominator. Here it becomes minus 1 plus 1. This is equal to 0. Yes, I got the resultant as 0. Then you can write that. Therefore, minus 1 by 3 is the 0 of the given polynomial. So, this is the minus 1 by 3 is the 0 of the given polynomial because we got minus 1 by 3 to be 0. We'll move on to the second one. In the second one, it's given that p of x is equal to 5x minus pi. Just substitute the value of 4 by 5 in the place of x. So I get 5 into 4 by 5 minus pi. Here 5 gets cancelled. Now I got the answer to be 4 minus pi. This too, there is no cancellation between 4 and pi. So you can't do it further. We can leave it off. We can, as it is not a 0, we can write that. Therefore, 4 by 5 is not the zeros of the polynomial. So, it is not the 0 of the polynomial. We'll move on to the third one. In the third one, it's given that p of x is equal to x square minus 1. They have given two numbers to be substituted. We'll check with the first one. P of 1, I am substituting p of 1. In that case, instead of x square, just substitute 1. If I substitute 1, it becomes 1 minus 1. So 1 minus 1 is 0. Yes, it is a 0 of the polynomial. Now let me check minus 1 too. So minus 1, substitute minus 1 wherever x is given. So it becomes minus 1 the whole square minus 1. Minus 1 the whole square is minus 1 into minus 1. Minus into minus will become plus, 1 into 1 will become 1 minus 1. So here minus 1 plus 1 0. So in the case both we are getting 0. So therefore the two numbers is the zeros of the given polynomial. We can write the result as yes, minus 1 and 1 are the zeros of the given polynomial. So both are the correct answer for us, zeros of the given polynomial in the third sum. We'll move on to the fourth one. In the fourth one, it is given that p of x is equal to x plus 1 into x minus 1. And x is equal to minus 1 comma 2. Here we are going to substitute instead of x minus 1 first. So p of minus 1 is equal to minus 1 plus 1. Substitute minus 1 in the places of x and the rest of the number write it as it is. So it becomes minus 1 minus 2. Here minus 1 into 1 is 0. This becomes minus 3. So 0 into any number will become 0. So first one, we are getting the number to be 0. Yes, then it will be a 0 of the polynomial. Now we'll check it with 2. For 2, 2 plus 1, 2 minus 2. I am just substituting the value of x to be 2. Here is also it's 2. Here it becomes 3 into 2 minus 2 is 0. So 0 into any number will be 0. Now I got 0 for both the case. Therefore, S minus 1 comma 2 are the zeros of the polynomial. So both are the zeros of the polynomial. We'll move on to the fifth one. In the fifth one, it's given that p of x is equal to x square and x is equal to 0. Just substitute the value of 0 in the place of x. So p of 0 is equal to 0 square. 0 square will be 0. As the answer is 0, we can write that yes, 0 is the zeros of the given polynomial. We'll move on to the sixth one. In the sixth one, it is given that p of x is equal to lx plus m, and they have asked us x to be minus m by l. So just substitute the value of m by l in the place of x. So minus m by l, p of minus m by l will be equal to l into minus m by l plus m. Here l gets cancelled. Minus m plus m. Here minus m plus m will become equal to 0. Therefore, minus m by l is the zeros of the polynomial. So now we'll move on to the seventh one. In the seventh question, it's given that p of x is equal to 3x square minus 1, where x is equal to minus 1 by root 3 comma 2 by root 3. Substitute the value of minus 1 by root 3 in the place of x. So p of minus 1 by root 3 is equal to 3 into minus 1 by root 3 the whole square minus 1. Here minus 1 into minus 1 will become plus 1. So 3 into 1 by root 3 into root 3. When there is a same number of root 3 into root 3, it becomes root 9. Just write the root and multiply the number. Here it's root 9. Root 9 is nothing but 3 square. Here root and square gets cancelled. The resultant answer is 3. Remember that if we multiply any two same number in root, that is root 3 into root 3, we get the answer 3. If it's root a into root a, you get a. Root 5 into root 5, you get 5. So leaving off the root, this for the same number, we get the number without the root. Remember in that case, here it becomes 3 minus 1. Here 3 gets cancelled, so 1 minus 1 is 0. Therefore, the first one minus 1 by root 3, it is the 0 of the polynomial. We'll try it with 2 by root 3. 2 by root 3. I am substituting the value of 2 by root 3 in the place of x. So 2 by root 3 the whole square equal to minus 1. Here 3 into 2 2's are 4. As I told before, root 3 into root 3 will become 3 minus 1. Here it gets cancelled. 4 minus 1 will be, here now it is 4 minus 1. This is equal to 3. So we are getting the first one to be the 0 of the polynomial. The second one is not the 0 of the polynomial. Here you can write it as minus 1 by 3 is the zeros of the polynomial. 2 by root 3 is not the zeros of the polynomial. I am writing it short. You need to write it carefully. We'll move on to the next sum. Next 8th sum. In the 8th sum, it's given that p of x is equal to 2x plus 1, where x is equal to 1 by 2. Just substitute the value of 1 by 2 in the place of x. 2 into 1 by 2 plus 1. 2 gets cancelled. It is 1 plus 1. 1 plus 1 is equal to 2. So We can say that 2, as it is 2, there is no 0. We can say that therefore 2 is, sorry, minus 1 by 2 is not the zeros of the given polynomial. So we have completed the sum. That's all with the sum. Thank you.